3.7 is functions. And we're going to start by talking about domains and ranges. And in the next course in intermediate algebra and also in college algebra, we'll go into a little bit more detail about these. But we're going to first start off with some basic definitions of domain and range. Okay, now domain is going to be the values of x. And your range is going to be the values of y. We're now going to also look at ordered pairs. And we're going to talk about what a function is after we look at the domain and the range. So I'm going to give you some ordered pairs. We're going to find the domain and range, make sure we know what the difference between the domain and the range is. And then we'll talk about what a function is, and then we'll go back to ordered pairs again and look at what's a function and what's not a function on the ordered pairs. So here's some ordered pairs, and I'm going to have you find the domain and range. And this is very, very simple. I'm going to give you some ordered pairs here. And I'm going to have you find the domain and range. Now, when we find the domain and the range, if we have duplicated values, we're only going to write those values one time. And when we look at ordered pairs, remember ordered pairs they go x, y. So the x is always listed first. So we're going to find our domain. And when we look at our domain, we're going to start with our smallest value of x. So what's our smallest value? We've got a 3, an 8, and a 9. And we use curly brackets to represent these. So our smallest value is a 3. So we start with the smallest one first. Now that 3 is duplicated, so we only need to write it one time. And then we also have an 8 and a 9 for values of x. So domain is going to be values of x. The range, sometimes called the target, is your values of y. So let's look at the range now. Your range is your values of y. And we always like to start with the smallest value. So these are our y values. Our smallest one is 2. So we have 2. We have a duplicated 4 value, but we only write that one time. And then we also have a 12. So that's your domain, which is 3, 8, and 9. And your range, which is the values of y, which is 2, 4, and 12. Okay, so that's your domain, and that's your range. Now, when we talk about functions, we need to look at an analogy of a function. Okay, a function is basically something goes in and something else comes out. And we use functions every day on almost everything. A classic example is our paycheck. Now, something goes in, something else comes out. So hours worked goes in, and what do you get out? You get out your paycheck. This is a very simple function. So x goes in, y comes out. And this is your input, and this is what you get out. Okay? So that's an example. Hours worked, you get a paycheck. A function just takes something and turns it into something else. And in mathematics, we focus primarily on numbers. So we use functions for numbers, but we can apply this to everything. We all know, okay, I have a job, I work so many hours, I get out so much money in the paycheck. That's an example of a function. Okay, now let's look at an example with numbers of something that's also still a function. And then we'll look at something that is not a function. So this is going to be an example with numbers. Same thing, hours worked. Okay. And you can also use gasoline grades. I've done that before with the gas pump. There's lots of different examples. So this is going to be our function again. And you can have multiple things going to one paycheck. Okay, so let's say we have somebody and they work 10 hours. And someone else works, 15 hours. And they get paid the same amount. Now, can this happen? Yes. How can they both get paid? Let's say one works for $10 an hour and one works for 15. So they can get the same amount, right? That can happen. Because if they get paid $10 an hour, you would get paid you'd get paid $100. And you can have that happen for both of them, right? Why can that happen? Okay, if you have somebody that works for 10 hours and they make $10 an hour, they get paid $100. Another person can work for 15 hours, and if they get paid $6.70, so this one gets paid $10 an hour, and this one gets paid $6.70 an hour, they get paid the same amount, right? Okay, they work different amounts of hours, but they get paid differently because they can still get that same $100. That's still an example of a function. So they can all get paid the same amount of money, but they work different hours because we know everybody gets paid a different wage. So maybe this person's been there longer than that one. This one gets $10 an hour. This one gets $6.70. This person has to work 10 hours to make $100. This person has to work 15 hours to make the same $100. But this is still an example of a function, right? Something goes in, something else goes out. This is one person here, and this is another person here. So that's an example of a function. You can have different employees working different number of hours to make the same amount of money. However, you cannot have the same employee get paid two different amounts. So this one was a function. This one is not going to be a function. Okay, so this one's not going to be a function, and we're going to talk about why this one is not a function here. Okay, this person works 10 hours, and they're supposed to get, let's make it easy again, let's say $15 an hour. So they get their paycheck, okay, and so this is one person here, and he's making $15 an hour. He works for 10 hours. His paycheck should be $150. Now another person works the same 10 hours for the same $15 an hour, and they make $400 on their paycheck. Is that possible? No, right? Because you've got the person that works for $15 an hour. They work for 10 hours. How much do they make? They should make $150, right? Somebody else works the same 10 hours. They make the same $15 an hour, but their paycheck is $400. What would that tell you? That would tell you that somebody made a mistake, right? Somebody typed in their information incorrectly, and they got paid the wrong amount of money. So that's why this is not a function. This is a mistake, right? If you make $15 an hour, and you work for 10 hours, you make $150, not $400. So you can't have that. How we know if ordered pairs are functions is we look at x values. And if any x value is repeated, it is not a function. Okay, so if any x value is going to be repeated, it's not going to be a function. So I'm going to give you some ordered pairs, and we're going to find the domain, the range, and you're going to tell me if this is a function or not. So we need to find the domain, range, and if it's a function. And here's the ordered pairs we're going to be looking at. And we need to see if this is a function or not a function. And we're also going to list out our domain and our range. And sometimes with something like this, it might be easier if we make a mapping, so we can visually see how each point on the x maps to the y value. So 5, these are x values. The first point is 5, 9. So 5 maps to 9. 8 maps to 4. 7 maps to 9. And 6 maps to 3. So these are our hours worked, and these are what they get paid. Now, are any of the x values duplicated here? No, they're all different, right? All the x values are different. So this is a function. So it's a function because all the x values are different. Okay, so we've got all these people, they're working different hours, they're getting paid different amounts. And that's fine. That makes sense. So all of our x values are different. So this is a function. Because these are your employees. These x are the employees and the hours they work. And these are y values over here. And these are what they get paid. You think about it like that. What about your domain? Okay, well, the domain is, again, the values of x. And so what do we have for our values of x? We start with our smallest one. And we've got 5, 6, 7, and 8. So that is your domain. And what about the range? Well, the range is going to be our values of y. And remember, we write duplicate values only one time. So we've got 3, 4, and 9. So those are going to be our values for our range. And it is a function. And why is it a function? Because all the x values are different. If the x values are duplicated, then that is just like what we had a moment ago. We had that one value and it split. Okay? We had one person and they were making two different amounts. So now let's look at one that is not a function. So this one's not going to be a function. I'm going to, again, give you ordered pairs. Let's say 3, 9, 7, 8, 3, 6, and 9, negative 2. X values, Y values. So we've got 3 maps to 9. 7 maps to 8. 3 maps to 6. And 9 maps to negative 2. So would this one be a function? Yes or no? Would this one be a function? No. Why not? It's not a function because the 3's are duplicated. So since the x values are duplicated, it's not a function. So since we have duplicate x values, it is not a function. Okay? So it's not going to be a function. And why is it not a function? Okay, it's not a function because we have a duplicated value here. I'm going to give you now a chart, and we're going to use this chart to also get the domain and the range. We're going to write these as ordered pairs. So we're going to write these as ordered pairs, and we're going to find the domain and range. These are our months here. And let's say this is our paycheck. Okay, so this is going to be our paycheck. Okay, and we want to look at ordered pairs. Now, first off, we know it's a function, right? How do we know it's a function? Do we have any months that are duplicate values at all? No, because this is your x, and this is your y. Now, what would they look like as ordered pairs? Well, as ordered pairs, it would be the month followed by the pay for that month. Okay, so we've got month and we've got the pay. So what would these look like as ordered pairs now? Month goes first because it's your x value. Pay is the y value. So in May, that's our x value, we got $1,500. And we have June, and what's your pay? $2,500, so that's your y value. And then we've got July, that's your x value. 2,300 would be your y value. So ordered pairs don't just have to be numbers. They can be something like this, where you have your months and you have the amount that you got paid. So in May you got $1,500, say you're a salesman. June you got more, and July you got a little less. Those are your ordered pairs. What would your domains look like? The domain is the values of what? X, right? Just remember domain goes with X. And so what's X? X is the months. So what would these be in ordered pairs? May, June, July. Very simple on these. It's just remembering the basic definitions. What about your range? Okay, your range is your y values. And your range would be, and you can put them in any order that you want. If you want to put them from smallest to largest, you can do that. So let's go ahead and put these from smallest to largest. We've got 1,500, we've got 2,300, and we've got 2,500. So those are your values that you get out. These are the months that you worked, and these are the paychecks that you got. Now, when we talk about function notation, we're going to be using a table to find values. So this is called function notation. And this is function notation. And that is going to be said f of x. So that's going to be our function notation here. And f of x is going to be the same as y. Now what we can do with function notation is I can give you a table and we can find the values that come out of this table. So I'm going to give you a table of values and I'm going to have you find different functions. So let's find two of these. Let's try to find f of 2. Now that 2, well, that is going to be the x value. Okay, so we want to use this table here that's provided. So it's provided to you. And we want to find f of 2. Okay, so if I want to find f of 2, that 2 is inside, and that's going to be your x value. So what's your x value? X value is 2. So that's your x value. So then what would f of 2 be? That's going to be right here, and f of 2 would be what? From our table, f of 2 would be negative 12, right? We find our x value, goes here, and what comes out is the y value. This is x, and this is f of x or y over here. So you find your x value, you look it up in the table, and you find the corresponding y value. What about f of, let's say, negative 3? What would f of negative 3 be? Okay, from our table, f of negative 3, this is your x value. Negative 3 goes in. What comes out? Positive 1. So these are not calculational at all. And there are a couple of these where I give you a table, and you use that table then to find out the corresponding value. You can also have, instead of a table, you can have an equation. And if you have an equation, you'll plug that number into that equation. So now we're going to evaluate these functions down. So we're going to evaluate down these functions. So let's say you're given f of x to be, we'll do an easy one first, 5x plus 10. And I want you to find f of 9. Okay, so on these, what you are given is you are given a function. So that's going to be given. You're given that f of x. I want you to plug in a specific number in for x, because this 9 here, that is going to replace the x in your original. So we want f of 9. So what are we going to do? We're going to rewrite our original. And wherever we have an x, we're going to use parentheses. And what's going to go in our parentheses here? The 9, because we're going to plug in the number 9 for x. And now we can work it out. 5 times 9, that's 45. Plus 10, that makes it then 55. So what do we know for our answer? F of 9 would be what? F of 9 here would be 55. Let's do a couple more of these with a little bit more complicated function. Some of these we may have to square. We may have to be careful with our negative numbers as well. So we'll do 2 more of these. And I'm going to give you 2 different functions. So let's say you're given this. So you're given f of x is minus 5x squared plus 3x minus 2. And I want you to find, let's use a negative number. How about f of negative 2? So we've got to be careful when we plug our values in, and we've got to be very careful with the signs. And remember, when we square a negative, it becomes positive. So that's going to be plugged in. So we're going to replace our x now with a negative 2. So I like to rewrite it with parentheses. And then I fill it in. That way it's easier. And so the x is replaced with our parentheses. And what goes in our parentheses? Negative 2. I picked this one on purpose because students a lot of times make mistakes with the signs and order of operations. I cannot cancel out these double negatives. Why not? Well, because order of operations says I do what first? I square first. When you cancel signs, that's multiplication. And squaring goes before multiplication. So really take your time and be careful with your order of operations. We're going to square first. And negative 2 squared becomes a positive 4. So you square that negative, it becomes a positive. And now we can go ahead and multiply. So negative 5 times 4, that's a negative 20. 3 times a negative 2, that's a negative 6. And then we have a minus 2. And they're all negative, so what do? We can add them all together. And that's going to then come out to be a negative 28. So f of negative 2 would now be a negative 28. You plug a value in, and you break it down. Let's look at one more of these. And then we'll go on to another topic with functions. So let's say you're given f of x is, how about 3x minus 1 quantity squared. This is what we're going to be looking at here. And I want you to find, let's say, f of 4. So what I want you to do is I want you to plug in that 4. We're going to plug in that 4, and then we're going to see what comes out. Number goes in for x, number comes out. So go ahead and plug in that 4. Watch your order of operations. So I plugged in that 4. 3 times 4 is 12 minus 1. 12 minus 1 is 11. And then after we've done the parentheses, we square. And 11 squared is then 121. So f of 4 would be 121. Okay. Very simple on these. You plug a number in, calculate it through, get your number out. Next, we're going to look at functions, and we're going to look at them as graphs. And we're going to see if these are functions or not. And to see if a graph is a function or not, we have to use what's called the vertical line test. Okay, so for the vertical line test, what we do is we draw vertical lines. If any line touches the graph, at more than one place, it is not a function. Okay, so vertical line test, what we do is we draw vertical lines. If any line touches that graph, at more than one place, then it is not a function. So now I'm going to give you some pictures of the graphs. We're going to look at these, and we're going to talk about if these are functions or not. Now, in later classes, when you move on to intermediate algebra, we're going to look at these graphs, and we're going to also be finding the domain and ranges. But in this class, we're not. All we're doing is we're determining if it's a function or not. So I'm going to give you 3 or 4 of these graphs, and you're going to tell me if it's a function or not. No calculations are involved at all. So we'll start off with this graph. This is going to be a line. So here's our graph. Okay, is this a function? Yes or no? Yes. Why is it a function? Our vertical line test says you draw vertical lines. If any line touches that graph at more than one place, it is not a function. Each line touches that graph at only one place. So therefore, this is a function. Now that's a function. What about a circle? A circle would not be a function. This is not going to be a function. Why not? It's not a function because look, if I draw a vertical line here, this line crosses at 2 places. 2 is more than 1, so that makes it not a function. Okay, so that blue line crosses at more than one place. So it is not a function. Okay, crosses at more than one place, so that is clearly not a function. Let's do one more. Well, actually we'll do 2, just to make sure we know the difference. One that is a function and one that's not. What about this picture right here, this u? Is this u a function or not a function? I draw vertical lines. Does any line touch that graph at more than one place? No, right? Each piece touches at only one place, so this is definitely a function, right? If it touches it at more than one place, it's not. Each one touches at only one place, so this is a function. And why is it a function? Because each line crosses that graph at only one place. Now, if I flipped it on its side, it would not be a function. If I flipped it on its side like this, this would not be a function. Why not? Because if I draw a vertical line here, this vertical line crosses at 2 points. Right? 2 different spots. So therefore, this is not a function. So it crosses at more than one place. And in intermediate algebra, you're going to do more with these graphs. Okay? In an intermediate algebra, what you would be doing is you would also be finding the domains and the ranges. But that's a little bit out of the scope of this course. So we look at the graphs, and that's about all we do with finding functions. We don't get the domains and the ranges. That's in the next course. What we're going to look at for the last part here is we're going to look at an equation. And we're going to be able to determine if an equation is a function or not. So an equation is a function if it can be solved for y. Okay, so we have to be able to solve it for y. And so that means no y to any power. So no y to any power, no y inside of a root, none of that. Okay, so no y to any power, no roots, no absolute values with the y. So let's look at something and let's see if this is a function. Do we think this is a function? Yeah. Okay. Why is it a function? Can I solve this for y? Yep. How would you solve this for y? You can clearly solve it for y. Because you can move that 5x over. Then you could divide by that 4, right? And then you get y equals minus 5/4 x plus 7/4. We were able to get y by itself, so it was a function. So this is a function. Okay, so you have to be able to solve it for y, for it to be a function. Not y squared, not y cubed, not the square root of y, none of that. You have to be able to solve it for y. So here's another one that we're going to see if this is a function or not. Okay, let's look at this one. Is this one going to be a function? Yeah, it's going to be a function, right? Because what's our goal? Our goal is to be able to get y by itself. Can we get y by itself? Yes, we can. Okay, we can get y by itself by simply moving that 6x squared over and the 3x as well. And then that leaves me with y equals now a minus 6x squared minus 3x plus 9. This is a function, and why is it a function? We were able to get the y by itself. As long as you can get y equals, it is a function. Most of the time, they will be functions. You have to be able to get y by itself. Here's an example of one that is not a function. This one is not a function. Why is it not a function? We have to be able to get y by itself. Okay, this is not a function because of the y squared. So for it to be a function, it has to be y, not y squared. So for it to be a function, it needs to be y, not y squared. So this is not a function. Okay, it's clearly not a function. Why not? Because of the squared. Okay, so for something to be a function, it has to be able to be solved for y. So no y squares, no y cubed, no square roots, none of that. It has to be y equals. Okay? So it doesn't matter what the x is, it has to be y equals. Now what about this one? Well, would this one be a function? You don't try to make it harder than what it needs to be. You don't really have to solve these out. You can look at it and tell. Is it going to be a function? Yes. How do I know? It's got y by itself, right? So it is a function. What about this one? Would that one be a function? Would this one be a function? No, why not? We'll just make it cute here. It can be anything. Okay, but this one's not a function. No, why is this one not a function? Why is it not a function? Because of that y cubed it. Okay, so that's going to make it then not a function. So what you want to look for to see if something's a function or not is you look and you make sure that the y can be by itself. If it's a y to some power or y to a root, it's not going to be a function. So you have to be very, very careful with that and make sure now that you can just get the y by itself. That now should finish up the last section of this chapter. I do want to show you how to do one of these questions. And then there's two questions that we're going to skip. And I want you to look at question number 2. And question number 2, we have already done this. We did this question in the previous section, and we did a lot of them. It's just presented a little bit differently. So for question 2, they give you this table. Okay, and this is what you get off of a graphing calculator. So we have a table. Now we want you to write the function in the form of y equals mx plus b. Now to get a function or a line equation, we need to have one of three things. We need to either have a point and a slope. Okay, that's one way of doing it. 2 points, or a point and a line equation. Well, if we look at our table, what do we have here? We've got a lot of ordered pairs, a lot of points. So let's try to use 2 ordered pairs, and we can pick any 2 ordered pairs that we want. So let's use these points, and I'm going to just pick 2 of them. Let's use that point -2, 1. And let's use that other point, let's use the 0. How about 0, 3? And you want to use those points, and you want to find the slope, and then use the point slope formula. Okay, so you want to find that slope, and then you want to use your point slope formula. So all the others we've covered. You can tell if this is a function just by looking at my ordered pairs here on question 1. You make a diagram. We did a couple of these. 3 and 4, we have done those. Okay, because 3 and 4 are just simply plugging the numbers in. We did a couple of those. 5, we did one of those where you write a table. We use the table to find values. So this is your x. You find the value that goes with it. Question 6, we did one very, very similar to this with paychecks instead of meals. But we did the paycheck and the month. So we made it ordered pairs. So we did one of those. Same thing with 7. You need to find what your phi would be in 97. We talked about how to use those tables. Question 8 is the one I'm going to have you not do. Okay, there's actually 2 of them, I believe, that I'm not going to have you do because I don't think we really need to cover that. So question 8 we don't have to worry about. 9 you can look at. We talked about those before. Okay, 10 we've talked about the range. So we know what the range is. Remember, range is the value of y. That would be your phis. 11, you can tell if that's a function or not. 12 we've covered. 13 is another one we're going to cancel out. I'm not going to have you find the domain and ranges. I think I'll leave that for intermediate for next semester, because that's something we can cover. We don't necessarily have to. 14 and 15, we've looked at those. 16, we've talked about it. Same thing with 17. 18, we've looked at one of those. 19 and 20, we've also looked at. So we've looked at an example of each one. Let's take a short break. We're going to come back, and we're going to talk about scientific notation and start reviewing for our final exam. We've got just 2 major topics left to cover. We've got to talk about polynomials and scientific notation. We're going to do scientific notation today because it's a very simple, easy concept to understand, and we'll do polynomials next week. So let's meet back here in about 10 minutes. So let's meet back at about, how about 10:35? So meet back here at around 10:35.